chapter 11, one-way ANOVA. Right. So learning outcome, after completing this chapter, you should be able to understand the concept of one-way ANOVA, right? The concept of one-way ANOVA and how to construct ANOVA table, right? And understand how to use ANOVA to analyze data from experiment. So, but before we continue, don't forget to sign in your attendance. So now, one-way ANOVA means that used to determine whether there are any significant difference on means between two or more independent groups. Right. So we already learned in hypothesis testing, chapter number 8. If you still remember, for two population group, if you want to find is there any difference between these two groups, so we're using t-test, right? So that is independent sample t-test basically. So for one-way ANOVA, it means that we want to find difference between more than two groups, two independent group, more than two independent group lah. So it can be 2, 3, it can be 3, 4, and so on lah. So if the means are significant different, so we can say that the variable had an effect on the variable being measured, which such as dependent variable. Right. So in independent sample t-test, as I said just now, right, we can only compare between two means, right? We already learned this in chapter number 8, right? In hypothesis testing for two population mean. So we want to find the difference between two mean. So the appropriate test is independent sample t-test. So if you have more than two group, right? So you cannot use independent sample t-test. You should use one-way ANOVA. One-way ANOVA means that you only have one dependent variable and one independent variable. So in this independent variable, it should be more than two group, right? More than two group. Right. The purpose of one-way ANOVA means that we want to determine is there are significant difference between between the group lah, between these three group, right? More than two group lah, right? So the test is called as analysis of variance lah, or what we call as ANOVA, right? Okay, done. So the purpose I ulang, right? So we want to determine the difference of the significance of more than three group, group 1, group 2, group 3, or group 4, right? Okay. So we're going to use ANOVA. In ANOVA, we are applying F-test. So F-test is a variation among sample mean divided by variation among individual in the same sample. So in ANOVA table, we already learned in chapter number 10, F is equal to mean square regression, regression divided by mean square error. So this is calculated in multiple linear regression, right? But in one-way ANOVA, we are not calling this as a mean square regression. We call this as a mean square treatment. Mean square treatment divided by mean square error, right? Of course, the design of ANOVA or analysis of variance are same as previous. We have source of the variation, sum of square, degree of freedom, mean square, and F calculated, right? So This is a definition. So F ratio means the mean square between group, right? Or between treatment divided by mean square within group or error, right? So this is also known as error, right? So F distribution, we learn as in chapter number 10, we know that in F distribution contain two degree of freedom. Degree of freedom 1 and degree of freedom 2. Sekejap, I kena mutekan WhatsApp ni. Banyak sangat dia masuk. Okay. So in F distribution, it contains two degree of freedom number 1 and degree of freedom number 2. So in degree of freedom number 1 means that the degree of freedom for group or treatment, right? So this is the degree of freedom for error or residual or within group lah, right? So F distribution is skewed to the right distribution because it came from a 2 chi-square distribution, right? So we're going to find the rejection area on the right hand side. This is a rejection area, and this is the critical value F alpha, degree of freedom 1 and degree of freedom 2. Okay, boleh? I think this one we already learned in previous chapter. Okay, so but the purpose of one-way ANOVA in this subject is different compared to previous chapter, right? Previous chapter we want to know whether the model is fit for prediction for multiple linear regression and simple linear regression, right? But in this topic, we want to know, is there any significant difference between this group, group 1, 2, 3, or 4, right? So example, so in the data type required for one-way ANOVA, as I said, it require one dependent variable and one independent variable. So dependent variable should be continuous, right? And independent variable should be a categorical data, right? Categorical data with more than two group, right? So if you have only two group, we should use independent sample t-test as we have already learned in chapter number 8. But in this chapter, one-way ANOVA, it require one dependent variable and one dependent variable and one independent variable, same as requirement in chapter number 8, right? Chapter number 8, t-test, also require one dependent variable and one independent variable, right? But in this case, we have more than two group, right? So we want to find the difference between this group, right? So this is an example. Dependent variables should be numerical, such as age, blood pressure, cholesterol level, right? Should be numerical. And this is a categorical independent variable, either group, drug A, drug B, and placebo, Malay, Chinese, Indian. We want to compare the blood pressure among Chinese, Malay, Indian. Is there any difference of the blood pressure between these three ethnic? Right? So example of one-way ANOVA. So a career office is studying the difference in starting salaries, which is the dependent variable, for different majors. So we have three different majors: computer science, engineering, and education. So we want to know, is there any significant difference of mean starting salary between graduate from computer science, engineering, and education, right? So this field, graduate from engineering, computer science, education, is an independent variable. Right? It's a categorical variable with more than 2 levels. Right. So starting salaries is a numerical data. Numerical data means a quantitative value. So it should be a dependent variable. Another example, a medical researcher wish to study the amount of time, right, takes for 5 different drug to work. Right. So we have drug 1, drug 2, drug 3, drug 4, drug 5. So we want to know uh, all these drug has the same it takes same time to take effect, or it different time to to make an effect, right? So this is example of a study design, right, in one-way ANOVA. So we want to measure the effect of drug on PEFR, compare between drug A, drug B, and placebo. Drug A, drug B, and placebo is a group lah, more than 2 groups, right? So this is another example. We want to compare the income or starting salaries among the ethnic, right? Malay, Chinese, Indian. So we have more than 2 groups. So if we only have 2 ethnicity, for example, Malay and Chinese, we want to compare the starting salary, we should not use one-way ANOVA because we only have 2 groups. Right? We should use independent sample t-test as we already learned in chapter number 8, right? Using t distribution. Remember t distribution? T x bar minus mu divided by s divided by square root of n, right? So this is assumption of one-way ANOVA. So the dependent variable should be numerical, right? And it should come from a random sample, right? And group are independent of each other, means that they are not related. So in each group, the observation should be normally distributed, right? For example, drug A should normally distributed, drug B also normal distributed, drug placebo also normal distributed. And the last assumption is equality of variance among the group, right? But in our chapter, our syllabus, we are not going to measure the normality assumption, the equality of variance. We just want to establish the one-way ANOVA table and test the significant difference on mean between the groups, right? Okay. So this is a hypothesis statement, right, for one-way ANOVA, right? For null hypothesis, so research question, we wish to know if drug have significant effect on mean PFR of the patient, right? So we have drug A, drug B, and placebo, right? So the hypothesis will be there are no significant difference in mean PFR in patient among 3 different drugs, which is null hypothesis mu1 equal to mu2 equal to mu3. And alternative hypothesis, we cannot determine the exact difference, right? But we can conclude at least one mean is not equal to 0 or is different from each other. So this is the indicator to conclude that there is a significant difference between groups, right? And of course, there are further investigation using a post hoc test that we are not covered in this chapter. Right. So this is how to construct one-way ANOVA. So let's say we have data, we have treatment level, means we have group, right? This is treatment level means group lah. This is independent variable, right? Let's say we have K group. So in each group, we have observation. This observation is numeric, right? These observations are numeric. So we need to find the total for each observation, for each treatment, for each group lah. We need to find the total, and we need to find the average of each treatment. And then from this total, we need to find the grand total for all treatment. Grand total for all treatment means that we plus y1, the total of y1. This is should be summation of y1, y1 y1j lah, right? Y1j. This is a summation of y2j and so on lah. Right, this is a grand total summation of double summation of yij. Right. Okay. And then we need to find the mean of all average. That means that this is the average for treatment 1, this is the average for treatment 2, average until average treatment K. We need to find the average of the average. Average of the average. This is average. So y bar, right, is equal to y bar 1 plus y bar 2 plus until y bar k divided by k. Right. K means number of treatment, number of group. Can you understand this concept? Right. Right. So we have learned in chapter 10 to construct one-way ANOVA table. We need to find sum of square total, sum of square error, and sum of square treatment. In this case, we are not calling SSR as sum of square regression because we are not modeling regression model, development regression model, but we try to find a significant difference of each group. So this is what we call sum of square treatment or sum of square group. Right? You can use this term sum of square group. Right? So to calculate the sum of square treatment is actually the variation due to the difference in the treatment means. Right? Sum of square error measure the variation due to random error. Right? So this is ANOVA table, constructing one-way ANOVA table. So the equation for sum of square treatment or sum of square group. So in some books, we will find this one called as sum of square between group. And this is also called as sum of square within group. Actually the same thing lah, right? It's a different term used by different books. So to find the sum of square treatment, right, it should be equal to summation of yi dot square minus y dot dot square divided by n. And this one should be divided by small letter n lah, right? So in this case, if you look at this one, y summation of yi dot square, it means that if you look at this one, this one. So this is the value, the total for each treatment. The total for each treatment means a yi dot, right? Yi dot means yi dot means I is equal to number of treatment group lah. So this is a treatment group. I is a treatment group, right? So yi dot means that you need to add every treatment, every value in that group. Right? Let's say you have group number 1. So you need to add every number observation in treatment 1. Right, so you will get this is y1 dot. This is a total of this observation for treatment number 1. Right? So this is a total observation for treatment number 2. Boleh faham? Okay. So the summation of yi dot, it means that you need to add everything, divide by number of treatment. So this is, you have, let's say you have 3 treatment, so you divide by 3 treatment, right? So this one y dot dot means the total for everything, for every observation, for all observation. Means that in this treatment 1, let's say you have 10 observation. At treatment 2, you have 10 observation. Treatment 3, you have 10 observation. The total of all observation is equal to 30 lah. Right, so capital N is equal to the total observation. Total observation, right? So this is basically the total of all value. Total of all value, right? So the total of all value, then you take a square, right? Power of 2 divided by number of observation, right? The small letter n here is represent number of treatment. So this is a total for each treatment, each treatment level, right? So divide by number of treatment. Later we will look into an example how to calculate this one. So k minus 1, k is number of treatment. So in this case, when I say treatment, it means that number of group lah. Treatment means group, right? Number of group. So this is sum of square treatment, right? And the last one, sum of square total. Sum of square total, we need to add every observation for each treatment and we square. Yij, it means that each observation and power of 2. Right? We square each of the observation and we take a summation for everything lah. And this is the same as this one. It's the same thing lah, same formula. Okay, is a total observation, maksudnya total all values, all observation, and we square divide by total observation. And capital N is total observation divide minus 1, and this is a degree of freedom for error, total observation minus number of group, right? And mean square treatment, the concept of mean square treatment same as previous. We divide sum of square treatment by degree of freedom for treatment. And for mean square error, we divide sum of square error divided by degree of freedom. And the value of f, mean square treatment, divided by mean square error. Okay. Any questions so far regarding one-way ANOVA? So now let's look at the example number 1. So this is a repeated thing. I don't want to explain this one. It's the same thing as previous lah. Huh? So now, before we go to example number 1, let's look at the hypothesis testing. So since we want to find the difference between group, the null hypothesis will be mu1 equal to mu2 until mu k. It depends how many group you have lah. If you have 3 group, it should be null hypothesis mu1 equal to mu2 equal to mu3. If you have two group, if you have then alternative hypothesis, at least one mu I is not equal, right? Or is different lah, right? So at least one mu I is not equal to 0 lah, or we can say is different. Okay. So for I equal to 1, 2, and 3. So we can use significant level set by the equation, either 0 0.01, 0 0.02, or 0 0.1. It depends on question lah, right? If the question does not state any level of significance, we use 0 0.05. And this is the test statistics, same as chapter number 10. Remember, multiple linear regression, we want to test the fitness of the model. So the concept is same as previous chapter. Okay, F, my mean square treatment divided by mean square error, and we can also use the p-value, right? We can refer from Excel output. And decision rule are same as previous. If the F calculated lies inside the rejection area, we reject null hypothesis. It means that we conclude that at least one pair is not equal, right? Okay. So now let's look at example number 1. So I don't have much example in this topic. I think I only have 9 example or 6 example only, right? So we have this data. Okay. Normally in final exam, right, I will not provide the value of total and average lah. I just give you this value saja. Like for example, this value saja. Right. Tak boleh color lah pula. So means that this area, this total and average will not be provided lah. Right. So you will given mixed technique, tensile strength only. Right. So once you got this kind of data, right, you need to find the total for each treatment. So you have 4 treatment here, treatment 1, 2, 3, and 4. So this is the observation for treatment 1. We have 4 observation. Right. In treatment 1, we have 4 observation. And this is the total for treatment 1. And this is the average of treatment 1. So how do you get this one? This one, you add 3129 plus 3000 plus 2865 plus 2890. And this one, you divide the summation of 118, summation of 11, sorry, kenapa dia hilang? So 11884 divided by 4. So you have 4 observation, you will get 2971. Okay. So this is what we call as yi dot. This is yi dot bar. Right. Okay. So this is the total for each total for every treatment. So 11884 plus 12,600 plus 11,000 plus 10,000, you will get 46,909. Okay. And this is the mean of the mean, right? X bar bar and Y by bar bar, right? So means that we find the average of this average. So we want to construct one-way ANOVA table for the experiment. So we want to know whether this mean of tensile strength have a significant difference on mixing techniques 1, 2, 3, or 4. So we start with sum or square total. So sum of square total should be summation of y ij square minus y dot dot square divided by capital N. And this is based on the formula given before, right, in this table, right? So this is sum of square total. So how to calculate this one? Sum of square Yij means that this is the total for, Yij means that the value for each treatment, right? For each treatment, we square. So this one, 3129 square plus 3000 square plus 2865 square plus until 2765 square. Okay. So minus y dot dot square. Y dot dot means that the summation of every observation. Right. So this one should be 46909 square divided by how many observations we have? 16. So divide by 16. Okay. Boleh? So this one is also equal to summation of x square. If you still remember in previous example, kan? In chapter number 9 and chapter number 10. Right? So we use calculator. Don't need to calculate by yourself. Huh? So I notice dalam test pun you ada calculate sendiri untuk standard deviation. I don't need to do that. So we go to 6 and find one minus variable, which is number 1. We include all the value lah. 3129, 3000, 2865, 2890. This is 3200. So make sure you input the data in calculator carefully. Right, salah input, got wrong result. Right, sudah input data? Right, so you go to option, click on 2, and you need to find summation of x square. So this one should be 138172041. So you just plug into the formula. So 138172041 minus with this value lah. So 1375 28392.6. Right? So this one should be equal to 6464364.8.437. Do you get the same answer? Dapat same value? Dapat? Ini? Ada soalan tak? Any question? Right. So this is a summation of total, sum of square total. Right. Next, we want to find sum of square treatment. So sum of square treatment means that the formula will be summation of yi dot square divided by n minus y dot dot square divided by capital N. Right. So if you compare with formula in final exam, right, let me show you the formula from final exam. Do we have formula? I don't. So this is a statistical table, okay? So the formula will be ANOVA. Yeah, this one. We don't have a proper formula. This is the formula lah, right? So basically the same thing lah. This is x bar divided by I think formula is quite dia guna formula satu lagi. Kalau kita tengok this one, dia guna formula this one. Right, it's the same formula lah, right? So n multiply with xi square minus x bar bar square, right? So you can use this formula as well, but I think I prefer this formula more than that formula. But later on kita tengok formula tu macam mana nak calculate. Right. So this one xi dot means that the total for each treatment. The total for each treatment. So this one should be 11,884 square plus 12,625 square plus 11735 square plus 10,665 square. This one divide by 4. Okay. So minus this value, right? 46909 square divided by 16. Okay. So this one should be 138018132.8 minus 137528392.6. This one should be 489740.237. Do you get the same thing? Okay. So next, to find the sum of square error, it should be sum of square total minus sum of square treatment. So this one should be 643648.437 minus 489740.237. This one should be equal to 153908.20. Okay. Boleh? So once we already have the value, then we create ANOVA table. Create ANOVA table. So ANOVA table format are same as previous. We have source of so this is sum of square degrees of freedom and mean square, and last is F value. So the first row we have treatment or we call as with between group. Right? So this one is also called as between group. Right? And then we have error or within and last we have total. Okay. So we fill in the value. So this is 643648.437, and this is 539, so this is 15908.20, is it? And the last one is 489740237. Right. Okay. So the degree of freedom for total is n minus 1. So our total observation is 16. 16 minus 1 equal to 15. And degree of freedom for treatment is number of treatment. So we have 3 group. Is it 3 group? Wait, treatment minus 1, I think. K minus 1. We have 4 group minus 1. So this is K minus 1. And this is N minus K, which is 16 minus 4. Should be equal to 12. Right? Or we can get 15 minus 3 equal to 12. Lah. Okay. Any questions so far? And to get mean square treatment or mean square between group, we just divide sum of square treatment divided by degree of freedom. So this one should be 163246.7457. You know how to get this value? This value divided by this value. And for some mean square error, this value divided by this value should be equal to 12825.6833. There are no mean square total. Huh? Mean square total, we don't have mean square total. So for F value, mean square treatment divided by mean square error. So we will get 12.73. Okay. Boleh? Any questions so far? Any question? Okay, pay attention on this kind of example. Focus more lah on this one. Right. So now, next step is we want to test the hypothesis whether the treatment has significant difference or no significant difference. So null hypothesis, mu1 equal to mu2 equal to mu3 equal to mu4, right? So alternative hypothesis, at least one mu I is not equal to 0, where I, ataupun we can say in other word, at least one pair of mean is differ, right? So let's use alpha 0.05, our test statistic. So F value is equal to 12.73, right? So the next step is to find the critical region. Critical region. So we draw a critical region skewed to the left, skewed to the right distribution. Oh yeah. Right. So this is the rejection area. F alpha, degree of freedom 1, degree of freedom 2. So F 0.05, degree of freedom number 1 is 3, degree of freedom number 2 is 12. So 3 and 12. So look at the statistical table, table number 8, I think. This is F value, right? So if you are given this kind of table, right, it's the same thing. You look at the notation here, F 0.05, 0.25, U and V. U means first degree of freedom, V is second degree of freedom. But in this case, 0.25. So we need to find 0.05. Right. So this is 0.05. So V number one, degree of freedom, 1 is 3. So look at 3. Degree of freedom number 2 is 12. So 3.49. Okay. So I think this kind of statistical table will be in your final exam lah. Right, betul? Because this is a UTP punya statistical table. So 3.49. So this is 3.49. So our decision reject since F calculated is more than F alpha, degree of freedom 1, degree of freedom 2, null hypothesis is rejected. So we can conclude that conclusion, we have enough evidence to indicate that there is a significant difference in mean tensile strength of cement by using 4 missing techniques. Okay. Ada soalan? Any questions so far? Right. Yes. Kenapa tak ada value? Ni. For, for this one. Ni memang tak ada, kita tak calculate mean square total lah. We just calculate mean square treatment and mean square error. Yeah. This one. No. This one, F ni mewakili semua ni. Sebab kita divide these two value. Right. So kita akan dapat satu saja F value. Okay. In final exam, please expect this kind of example lah. Example number 4 ni. Without this value lah. Without ANOVA table. We need to construct ANOVA from scratch. Will be 10 marks for this kind of question. Right. It's the same thing. We have 3 treatment. So we need to calculate the total for each treatment and the grand total. Right. You just plug into the formula saja. Right. Let's look at example number 2. You want to see this example? Or you nak simpan this one for your practice? Nak tengok. Join. Practice. Okay. Right. Okay. Now, let's look at this one. So, we have attempt to speed up the cleaning process of oil spill in the sea. Experiment was carried out on 3 different methods. Method A, B, and C. The effectiveness in cleaning up the oil spill was compared by recording the surface area clear in 1 hour of each method. Right. So the result shown in this table. So this is the surface area in square meter. So now we want to construct ANOVA table. In this case, we know that K equal to 3. So now we need to calculate the total for each treatment. Right? Put line macam ni lah. Okay. So the total for treatment A, method A is equal to 285. So this is total. Right. The total for B, 236. The total for C is 344. So grand total is how many observations we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 observation and 3 treatment. Right? So first step, we need to find the grand total, which is summation of this one we call as y dot dot, right? So we plus everything. This one should be 865. And then we need to find the summation of yij square. Summation of Yij square, we just plug in into the form calculator. Include everything, 57, 53, 64, 49, 62, and 61, 52, 57, 66, 60, 55, 55, 59, 60, and 55. So altogether 15, right? So we need to find summation of x square, which is equal to 50185. So this is 50185. Right. So summation of a sum of square total, which is equal to summation of Yij square minus y dot dot square divided by capital N. Right. So this one is 50185. 185 minus 865 square divided by 15. Okay. So this one should be equal to 303.3333. Right? Dapat? This is sum of square total. So now sum of square treatment is equal to summation of yi dot square divided by n minus y dot dot square divided by capital N. So this one should be equal to 285 square plus 236 square plus 344 square divided by 3 minus 865 square divided by 15. Sorry, this is not divided by 3. Right? This is divided by how many observation for each treatment? This is 1, 2, 3, 4, 5. This is 5. 1, 2, 3, 4. 4. 1, 2, 3, 4, 5. 6. 6. Nampak? Tadi sebab sama semua kan? Sebab tu 4. Right? So, but this one kita ada different level of observation. So this one should be equal to 4981. I think kalau you masuk dalam calculator, you will get 10 lah. Saya letak tepi ni 10. Okay, so sum of square error should be equal to 303.33 minus 10 should be 293.33. Simple kan? You just need to have two kind of total. First total by each treatment and grand total. Then total for each observation square. So next we construct ANOVA table. So this is source of variation. This is sum of square. This is degree of freedom. And this is mean square. square. Don't confuse with simple linear regression, multiple linear regression, and one-way ANOVA. The degree of freedom for each techniques are different, okay? Boleh faham? Techniques for one-way ANOVA as simple linear regression, degree of freedom for regression should be only one. Degree of freedom for multiple linear regression, for regression kan, kita ada K, right? Should be equal to K. And this one, K minus 1. Different formula. And last is F value. Right, so we have treatment and error. And last is total. So plug in the value. So this is 303.33. This is 293.33. This is 10. And degree of freedom for treatment is K minus 1. So we have 3K minus 1 equal to 2. This is 15 minus 1, 14. This is 12. Or N minus K. So the 10 minus divided by 2 equal to 5. 293.33 divided by 12 should be equal to 24.44. So this one should be 0.2045. Right? Okay. So the next step is to construct a hypothesis test. So null hypothesis mu1 equal to mu2 equal to mu3. So we only have 3 kan? Alternative hypothesis, at least 1 mu I is not equal to 0, where I equal to 1, 2, 3. Alpha 0.05, test statistic, F equal to 0.2045. And next is critical region. Right. We just need to draw the rejection region. Right. Oh yeah. So this is F alpha, degree of freedom 1, degree of freedom 2. So F 0.05, 2, and 12. Right. Degree of freedom number 1 is degree of freedom for treatment. Second, degree of freedom for error. Right. So look at the statistical table, 0.05, U2, V, which is 12. So 3.89. Nampak? You know how to read this one? 3.89. So degree of freedom number 1 is 2, which is U, right? Degree of freedom number 2, right? The second one, number 2 is 12. 3.89. Okay? Jangan ada yang salah. Salah ni malu. 3.89. So next, our decision. Since F calculated is less than F alpha, degree of freedom 1, degree of freedom 2, null hypothesis is accepted. Right. So we don't have enough evidence to conclude there is a significant difference in mean surface area using three methods. Okay. Any question? No. Belakang? Right. You want 5 minute rest? Go on. Go on. Come on. Nah, 5 minute rest. Okay. So you all okay ke? Quiz hari Khamis malam ataupun hari Jumaat malam? You ada test bila? Khamis malam. So buat hari Jumaat lah. Ha? Jumaat malam lah. Ha? Okay. So nanti I inform Dr. Ibrahim lah. Di Jumaat malam. Semua tak boleh lah. Hari Khamis tu semua tak boleh lah. You test hari Khamis malam pukul berapa? 1.5 jam. Oh. Okay, tak apa. Saya info lah hari Jumaat lah. Quiz. Okay, kita continue. Ini you nak try buat sendiri? Sendirilah. I tak mau tunjuk lah. Okay. So, I bagi tahu the F value should get 2.0233. Right. The F value is 2.0233. So, you compute by yourself. Right. Try recompute balik. Jangan tengok total ni. Try compute balik yang baru lah. And then test the hypothesis to compare the different temperature effect on density of the brick. Right, let's look at example number 4. Which is, we don't have much example kan, ada 9 saja. Tak banyak. So example number 4, look at this one. So we want to complete the table based on the data provided. We have beginner, intermediate, and advanced. So K is equal to 3. So from here we know that R is equal to K minus 1 equal to 2. Right? And then T is equal to N minus 1. So which is equal to, this is 1, 2, 3, 4, 5, 15 minus 1, 14. Right? And S equal to N minus K equal to 15 minus 2, 3 should be equal to 12. Right. So this is the value for R, S, and T. So we want to find the value of Q and P. So how to find value Q and P? Huh? So tengok apa yang dia bagi dulu, okay? So what is the information yang kita boleh dapat dengan senang tanpa without manual calculation? You see, we have the mean square error here, mean square between group, kan? Mean square treatment. And we also know the value of R. The value of R is equal to 2. So to get mean square regression between group, sum of square between group divided by degree of freedom. So to get the sum of square, we reverse lah, manipulate balik. So this one, P should be equal to 5.067 multiplied with 2. So this one should be equal to 10.134. So we don't need to calculate from scratch. Okay. And then to find Q, very simple. Q should be equal to 10.134 plus 11.6. So this one should be 21.734. Right, very simple, right? And then U should be equal to 11.6 divided by S. S equal to 12. So this one should be equal to 0.9667. And then from here, we can find the value of V, which is 5.067 divided by 0.9667. So this one should be equal to 5.2. 5.2 415. Right, very simple to find the value from ANOVA table. Right? Any questions so far? So from here, based on the p-value, can you conclude that there is a significant difference in the average time taken to complete the task among 3 different level of trainees? So null hypothesis, mu1 equal to mu2 equal to mu3. So mu1 is a basic, mu1 is a beginner, mu2 is intermediate, mu3 advanced. Alternative hypothesis, at least 1 mu I is not equal to 0. And we use alpha 0.05. The p-value equal to 0.023. Our decision, since p-value is less than alpha, null hypothesis is rejected. Right. So since we reject null hypothesis, our conclusion will be there is a significant difference Okay. All right. So this one should be very easy. Okay. Boleh? So let's look at example number 5. So this is the same concept as previous example. So from here, we have how many group? So we have senior manager, junior manager, senior employee, junior employee, and secretary. So 1, 2, 3, 4, 5. So K equal to 5. So to complete this value, Q should be equal to K minus 1, should be equal to 4, right? And then from here, we can find the value of P, right? So P is 7141.664 minus 418.205. So 6723.459. And the value of R is equal to 418.2, 418.205 divided by Q is equal to 4. This one should be 104.5513. Okay. Simple kan? Right? But unfortunately, this kind of question will not be in your final exam. Kan? Senang sangat. Kan? So the question, I don't tell others, okay? Don't tell others. All right. So this one should be 104 and S should be equal to 6723.459 divided by 102. So this is 65.9163 and so on. And then we need to find the value of T should be equal to R 104.5513 divided by 65.9163. So this one should be equal to 1.5861. Right. The next step is we need to state the null and alternative hypothesis. So this one always remember. So null hypothesis mu1 equal to mu2 equal to mu3 equal to mu4 equal to mu5. So we have 5 group kan. So alternative hypothesis at least 1 mu I not equal to 0. Where I equal to 1, 2, 3, 4, 5. Right. So using F test, is there any evidence to reject null hypothesis at 5% level of significance? This kind of question definitely will be asked in final exam lah. So alpha 0.05. Test statistic equal F equal to 1.55861. Critical region ayo, hari ni dia senang nak buat shape. 4 and 102, right? So this one should be 4. This is 0.05. Make sure you look at the correct alpha. 0.05, 4, 102. Where is 102? We don't have 102 here. It should be, can we take 2.53 plus 2.45 divided by 2? Right? 2.53 plus 2.45 divided by 2. So this one should be equal to 2.49. So our decision, since F calculated less than F alpha, dF1, dF2, null hypothesis is rejected or accepted. Null hypothesis accepted. Okay. So we don't have enough evidence to reject null hypothesis. So we can conclude that there are no significant difference between on mean number of cigarette among their employee lah. Right. The employee. So Okay. All right.